Hello everyone, welcome back to my channel Mind Your Exam. In this video, we will be studying another technique for performing error detection, which is the cyclic redundancy check or CRC. So to compute CRC, you need to have a given frame in which there would be certain number of bits. Now the frame bits are those bits, the data bits, in which you want to check whether an error has occurred during the transmission from the sender side to the receiver side. So you will always have the data bits, which we also known as the frame bits. And once you have the frame bits, the sender and receiver decide upon the generator code. A generator code is another set of bits. It is a fixed pattern which is decided by the sender and receiver so that it can be utilized to compute the cyclic redundancy check. Okay, so to compute the CRC, you need two things. First is the data, which is present in the form of bits, which is also known as frame bits. And the second is the code or the bit pattern that is agreed by the sender and the receiver. Now, this generator code generally has a 1 at the most significant bit and a 1 placed at the least significant bit. This is a customary that the sender and the receiver follow. Now, if the frame has d number of bits in the data, then R is the number of bits that are present in the generator code. So, if the frame contains d bits and the generator code contains R bits, then our second step at the sender side would be to append R minus 1 number of zeros at the end of the frame bits. So, the original frame contained d bits. Now we will add R minus 1 number of zeros at the end of these bits. So the resulting code would be of size d plus R minus 1. So d bits come from the original data bits and R minus 1 bits come from the additional zeros that we have added at the end of the frame bits. Now the next step at the sender side is to divide this particular d plus R minus 1 code word that we have obtained by the generator code. So the dividend is the code word that is obtained by appending the frame bits and R minus 1 zeros, and the divisor is the generator code that was agreed upon. Now in this case, to perform the division, you use the XOR arithmetic rules. XOR arithmetic, what it is? It basically says that if two bits are exactly the same and you perform XOR operation, then the result will always be 0. But if two bits are not the same and you perform XOR, then the result would be 1. So you use XOR arithmetic to divide the d plus R minus 1 code word with the generator code. And after division, you obtain the remainder. Now this remainder is the CRC checksum or the CRC remainder. And this remainder will now be replacing the R minus 1 zeros that we added to the dividend. So once we have got the remainder, we will remove the R minus 1 zeros that we added at the end of the frame bits, and in place of these R minus 1 zeros, we will put the remainder. So why did we add exactly R minus 1 zeros? Because the CRC checksum or the remainder that is obtained after the division would have one less number of bits as compared to the divisor. The divisor, which is the generator code, had R bits. So the remainder for this division would always have R minus 1 bits. And now once we have got the remainder, we are replacing the R minus 1 zeros with the actual remainder. Then as a last step, the sender will transmit this newly obtained code to the receiver. So the newly obtained code is consisting of the original data bits, that is the frame bits, and it has the remainder of this computation appended to the end. So at the receiver side, what will happen? The receiver will again perform the division. It will use the received code word as the dividend and divide it with the generator code. Now this generator code is again acting as a divisor, and the dividend is the content that has been sent by the sender. Now if after performing the division the remainder is 0, then the receiver knows that no error has been detected. Otherwise, if the remainder is non-zero, the receiver knows that some error has been detected. And that is how the CRC, or the cyclic redundancy check, helps to calculate or to find out whether an error has occurred or not, that is performing error detection. So now let us take an actual example and understand the concept of CRC. So in this example, we have the original frame bits as 1101, 011, 011. This is the sender side. So the first step we will do is count the number of bits in the divisor. The divisor has 5 bits, so we will add 5 minus 1 number of zeros to the end of the frame. So we will add 4 zeros to the end of this frame bits. Now we will start the division, which is the XOR arithmetic. So the only two options for the quotient are either you will have a 1 bit or a 0 bit, okay, because it is binary division. So now, since the first 5 bits form a pattern that is greater than this particular value, so the first digit in the quotient would be 1. That is, this value multiplied by 1 will give you 10011. And when we perform XOR arithmetic, we'll get 0 and 1 gives you 1, 1 and 1 gives you 0, 0 and 0 gives you 0, 1 and 0 gives you 1, and 1 and 1 will give you 0. Since the most significant bit is not considered as a 0 at the most significant bit is not considered valuable, so we do not write the most significant 0. If it would have been 1, we would have definitely written it. So now, since the number of bits here is less than the number of bits in the divisor, so we pull down one digit as from the top and write it down here. Now this value is exactly same as the divisor. So we again multiply the divisor by 1 and perform the XOR arithmetic. The XOR arithmetic would come out to be 1 and 1 would give you 0, 0 and 0 would give you 0, 0 and 0 again give you 0, and 1 and 1 would also give you 0. Now since these 4 bits are less than the number of bits in the divisor, so we pull down one bit from the top and then perform XOR arithmetic. In this case, divisor will be multiplied by 0 because this particular value is less than the divisor. So the divisor multiplied by 0 would give you all zeros, and here the result of XOR arithmetic would be 1 0 0 0. In this case also we will pull down the next bit from the top and then multiply the divisor by 0 and continue with the XOR arithmetic. In this case, we will get the value 0010. It is time to put down the next bit, which is a 1 in this case. Again, this value is smaller than the divisor, so multiply the divisor by 0 and perform the XOR arithmetic here. By the XOR arithmetic, we get this particular value, and next we pull down the next bit, which is another 1. Now this value is again smaller than the divisor, so the quotient will have another 0 and we will continue with the XOR division. This time the XOR division would give us the value as 1011 and we pull down the next 0, which is this. So this value is greater than the divisor, so we will multiply the divisor by 1 and perform the XOR arithmetic. Here, the value that we will get would be 0 and 1 would give you 1, 1 and 1 gives you 0, 1 0 gives you 1, 0 0 gives you 0, and 1 1 would also give you 0. So we pull down the next 0 here. Here, this value is smaller than the divisor, so multiply by 0 and you get all the zeros here. Performing the XOR arithmetic, you will get this particular value and then you will pull down the second last 0. When you do that, this value is greater than the divisor. So you multiply the divisor by 1 and perform the XOR arithmetic. This will give you the result as 0, 111, and the last 0 will be pulled down. In this case, we have got our remainder as 1110, since the most significant, in this case, you will multiply with a 0. The divisor would be multiplied with a 0, and you will perform the XOR arithmetic. Again, you will get the remainder as 1110. Now, this has been done at the sender side. So, the sender has computed the CRC checksum, which is this particular value. So, this particular value will be appended at the end of the frame bits. So, the frame bits originally were 1, 1, 0, 1, 0, 11, 0, 11, right? And now we have these 4 bits. So these will replace the last 4 zeros that we appended at the sender side. So here we have written the checksum 1110. Now this is the receiver side. The receiver will receive this entire code, the frame bits followed by the checksum bits, okay? And it will again perform this division using the divisor that is agreed upon. So let us see what is the result of this particular division. In the first place, when we perform this division, we multiply by 1 and we perform the XOR arithmetic. So let us see. We get the result as 1, 0, 0 and 1. Then we pull down the next bit and then we multiply by 1 again. We perform the XOR arithmetic. 1, 1 gives you 0, 1, 1 again gives you 0, 0, 0 gives you all zeros. So you pull down the next one. In this case, you multiply it by 0 as I have just told at the sender side, and in this scenario, you will get the result as this. Then you pull down the next digit, which is a 0. Again, you will multiply the divisor by a 0 and perform the XOR arithmetic. When you do so, the result of the XOR arithmetic would be this, and you pull down the next digit. All this is happening at the receiver side. It may seem to be as the same process that we did as the sender side, but the receiver does not know of what has already been done at the sender side. The receiver has to find out whether an error has occurred during transmission or not. So it is again performing the entire division, and we will see that the receiver will be able to figure out whether an error has occurred or no error has been detected or the transmission has been successful. So in this scenario, when you get 10110, you multiply the divisor by 1. In this case, you perform the XOR arithmetic, which would come out to be 0101, and you pull down the next one. Here, when you do so, you multiply by 0 again and perform the XOR arithmetic at this level. The value would be 0, 1, 0 and 1. The second last one will be pulled down, and since this value is greater than the divisor, so multiply by 1 and let us see what is the result of XOR. XOR will give you 0, 1, 1 and 0, and at the end you pull down the 0. Here what will you do? You will multiply by 1 by all zeros. Okay, so I'm sorry, I did a mistake here. This value should have been 1 because we pulled down a 1 from here. So here we multiply by 0 and you get here 1. Then again you pull down a 1. Here you get 1 and 1 will give you 0. 1, 0 would give you 1. Now in this case, here also, Okay, so there was a mistake from my end. Here we had to pull down a 1. Then we multiplied the divisor by 1 and we got this value. Now when we perform the XOR arithmetic, this is 1 and 1 giving you 0, 1 and 1 giving you 0, 1 0 giving you 1 and 0 0 giving you 0. Next again we pull down a 1 and multiply by 0. So you get the remainder as 1 0 0 1. In this case, you again pull down the second last one. Then here you multiply the divisor by 1 and perform the XOR arithmetic. So the value that you will get here is all zeros. And in this case, when you pull down the last 0, the final remainder will be all zeros. So as we have seen that when you get all zeros as the remainder at the receiver end, then what do you have to infer? That here no error has been detected, because when the receiver computed the checksum and you divided, the receiver divided the dividend with the divisor that was agreed upon, then the value of the remainder is coming out to be all zeros. So that means no error has been detected. So this was all for today's video. I hope you have understood this lecture. Thank you for watching. Till we meet in the next video, mind your exam.